Hey there, Mr. Weaver here, and this is 8th grade Module 6, Lesson 5, Write and Solve Systems of Equations. After this lesson, you need to be able to write and solve a system of equations that models a real-world scenario. Let's learn. Write and solve systems of equations. You can write a system of equations to solve real-world problems. So for example, Benjamin and Harper went shopping at the school store. Benjamin spent $7 on 2 packages of pencils and 5 folders. Harper bought 1 package of pencils and 4 folders and spent $4.25. What is the cost of a package of pencils and a folder? This is how a lot of these systems of equations are going to work in real-world situations. We're going to be given some information and we have to piece it together to figure out how much something costs or how many we bought or how many people attended the event. As long as we're given 2 equations, we can set it up and use one of our methods. So to do this, first we're going to pull out the information that's relevant. So here it said 2 packages of pencils and 5 folders cost $7. It also told us that 1 package of pencils and 4 folders cost $4.25. It didn't matter who bought them. We're trying to figure out pencils and folders and how much they cost. So that's what our equations need to be about. Once we've pulled out the basic information, we can use variables to define what we do not know. So here they're saying use X to represent the package of pencils and Y to represent the cost of the folder. As you're going through this, sometimes it's just as helpful, if not even more helpful, to use the letters of the items that they stand for. So instead of X here, had you wanted to use P for pencils and F for folders, it might make more sense to you in the context and you can solve it the same way. Then when you get to the end and you're solving it, you realize you solved for P, so P must have been the pencils. F was the folders. Or you can use X and Y, just as long as you define ahead of time which one is which, so you're not trying to figure that out at the end. So once we figured out what variables we want to use, we can write our equations. So for Benjamin, we don't really need the name of the person, but he bought 2 pencils and 5 folders. Most of these are going to be a plus because you're getting more than one thing. And his total was $7. For Harper, she bought 1 pencil and 4 folders, and the total was $4.25. Once we've set up our equations, we can use any of the 3 methods that we've done, so graphing, substitution, or elimination, to solve it. And it's going to be helpful for you to look at what the equations look like to decide. Take time to pause and reflect. Are there any methods in solving these systems of equations that you're not yet comfortable using? And what could you do to better understand each method? Pause the video and write down your thoughts. Example 1. Write and solve systems of equations. The sum of 2 numbers is 39. Their difference is 7. Write and solve a system of equations to find the 2 numbers. So here's an example of a type of system of equation. There's not a lot of context that goes with it. It's more like a puzzle and you're trying to figure out what the 2 numbers are. So let's start with the words. It tells us the sum of the 2 numbers is 39. It also told us the difference of them is 7. So if we say X is one of the numbers and Y is the other number, then when we write the equation, first the sum means add. So if we add our 2 numbers together, X and Y, our total was 39. Difference means subtract. So if we find the difference between them, we subtract the 2 numbers, and that difference was 7. So these are our 2 equations that we're going to use to figure out the 2 numbers. Once we have our equations, let's use any of the 3 methods to solve our system of equations. So since they're both set up with something X and something Y equals a number, let's use elimination. So we're going to add the 2 equations together. So X plus X gives us 2X. These were both a single X. Now we have 2 of them. I have positive 1Y plus negative 1Y. Those are opposites. They make 0. And then 39 plus 7 is 46. My Y was eliminated. So 2X is equal to 46, which means X is equal to 23. Once we figured out that X was 23, that's one of our numbers. Now we have to figure out the other. So we can choose either of the 2 equations to substitute back in. If we plug in 23, let's just use this top one. X plus y is 39. So we know x is 23. So 23 plus something is 39. What is my missing value? I can subtract 23 from both sides and find that y is equal to 16. So if x is 23, y is 16. If I use the other equation, I could find that 23 minus 16 is 7. Those numbers have a difference of 7. So now let's interpret our solution. Since we're given a word problem, we need to be able to put it back into the context and define what each number means. Here we were just talking about two numbers. We got x was 23 and y was 16. So that's your solution. That just means that the two numbers are 23 and 16. Check your understanding, read through the situation, and answer all three parts. Pause the video now and complete the check. Check your answer. First, for part A, which two equations represent the situation, with x being one number and y being the other? We need to say the sum, so that's your adding part. If we add the two numbers, we get 14.5. There's that equation right there. Their difference, so subtracting them, is 5.5. There's our equation there. What is the solution? You should have found that the two numbers are 10 and 4.5. If we were to solve this, we would just use elimination. So x plus y and x minus y give us 14.5 and 5.5. Add them together. My y is eliminated. 2x equals 20, so x equals 10. Plug it back in. 10 plus something, which that's your y value, is 14.5. So y must be equal to 4.5. So that would fit right there. What does this mean? Interpreting our solution just means that the larger number was 10 and the smaller number in this was 4.5. They added together to get 14.5, and subtracting them, we got 5.5. Take time to pause and reflect. Did you make any errors when completing this check exercise? If you were to not check your answers, which we did not do with that check, what can you do to determine whether or not your solution is reasonable? Pause the video now and write down your thoughts. Example 2. Write and solve systems of equations. Creative Crafts offers scrapbooking lessons for $15 per hour plus a $10 supply charge. Scrapbooks Incorporated offers lessons for $20 per hour with no additional charge. Write and solve a system to determine what number of hours is the cost the same at each store. So to figure out how many hours will the cost be the same, we're essentially writing an equation for each, and if they're the same, we need to make them equal. In terms of systems of equations, that equal part is the part where they intersect. That's how we get our solution. That's when it's the same point on both lines. So let's write our equations. For Creative Crafts, the total cost is $15 per hour plus $10 charge, where Scrapbook Incorporated is just $20 per hour. Let's say X is the number of hours and Y is the total cost. If you want to use H for hours and C for cost, so it makes sense logically with the letters, feel free to do so. For Creative Crafts, our cost is going to be $15 per hour plus 10 extra dollars. So if our cost was $15 each hour plus 10 extra dollars. For Scrapbooks Incorporated, our cost was just $20 times how many hours. There you go. There's our two equations. Now, if I want to solve these, I need to choose which method is going to be the most efficient. I see they are both set up y equals and then the rest of the expression. They're both written in slope-intercept form, so graphing could be one of the easier ways to do. Or they're both solved for a variable already, so substitution would be one of the more efficient methods as well. This is not set up for elimination. So to solve this one, let's use graphing. So we are given a graph, we need to graph them both on the same plane. And again, the solution is where the two lines are intersecting, since that's when the point is the same on both lines. So if I graph the first one, my y-intercept was 10, and it was going up $15 each hour. So up 15 again. There's my next easy point to go through. 2 hours went up 30. So 15 each hour. That was my first line. The second one, $20 per hour. It went up $20 for 1 hour, $20 again for another hour, and so on. Where are my points intersecting? They appear to intersect at 2 hours and $40. So at 2:40. With graphing especially, we should double check by replacing and making sure that that coordinate does in fact work for both things. It's possible it could be very close. What if 2 was actually $39.50? By checking, we would see that that would be wrong. So 2 for x, 40 for y. If I plug them in, 15 times 2, $30 for 2 hours, plus the $10 supply charge. It does cost $40. If I plug in 2 and 40 for my $20 per hour, 2 hours at $20 per hour is also $40. So since we plugged the point in and both of them were true, that is our solution. It's 240. What this means in the context, if you took lessons for 2 hours, so X was 2, the cost at both stores is the same at $40. So if you were looking to figure out which one was cheaper, it would not matter if you went for 2 hours, they both cost the same. And that's going to be a lot of the context things. You're trying to find out when the two situations are the same. Check your understanding, read through the situation, and answer all 3 parts. Pause the video now and complete this check. Check your answer. First, the two equations where x is the number of months and y is the amount paid, you should have picked B and D. So for B, it says it's one-time fee of $100. So just once we pay $100, and then monthly it's 10. So if x is the number of months, we'd have to multiply that by 10. That gives us equation B. The other one only has a monthly fee of 20, so we would just take our months, x times 20. What is our solution? You should have found that it was 10 and 200. For this one, since I don't have a graph readily available, I'm going to use substitution. And when I do that, if I take one equation and plug it in for the variable of the other, I end up with 20x equals 100 plus 10x. Subtract 10x from both sides, I get 10x equals 100. So x is 10. I'm going to plug it in to my shorter equation. 10 times 20 is 200. Interpreting this, that means they pay the same amount at 10 months, where the total is $200. If I plug in 10 here, just to double check, 10 times 10 is 100, plus 100 more is also 200. So for both of them, 10 months, the cost was $200. Example 3. Write and solve systems of equations. A total of 75 loaves of bread and bags of popcorn were donated for a bake sale to raise money for the football team. There were 4 times as many bags of popcorn donated as loaves of bread. Write and solve a system to determine how many of each item were donated. So we want to know how many of each item. So how many loaves of bread, how many bags of popcorn. Here, our clues to figure it out are slightly different. And this is a common format to try to figure stuff out. So it tells us the total for these two things. So loaves of bread and bags of popcorn. Altogether, there were 75 items that were donated. So if we combine them both together, all the items was 75. That's a very common thing to see. We also are told there were 4 times as many popcorns as loaves of bread. Next, let's define our variables. So here they're saying x is the loaves of bread, or if you want to use B for bread, go for it. Y is our popcorn, or P for popcorn. To make our equations, the first one in this type of situation, we're going to add the two items together, and we know there were 75. So X is how many loaves of bread there were. Y is how many bags of popcorn. Added together, there were 75 of them. We also know that there were 4 times as many bags of popcorn. So here's your bags of popcorn. We would get that number by taking the loaves of bread, which is X, and multiplying it by 4. So we could say Y equals 4X, or P equals 4B. As before, let's solve our system of equation. This time, let's use substitution. The reason we want to use substitution this time is we had that second equation that was just Y equals 4X. X plus Y, that's not written in the format that we want for graphing, and Y equals 4X is not written in the format that we want for elimination. But since it's solved for Y, substitution will work well. So since Y is equal to 4X, let's plug in, instead of Y, we'll put 4X in its place. Now solving, X plus 4X, combined like terms, we get 5X. So 5 times X is equal to 75, which means X was equal to 15. Now that we know that X, or our loaves of bread, is 15, then we can plug it back into either equation. If we plug it in here, we find that we need 60 more to get to 75. Or if we plug it in here, 15 times 4 is also 60. So either way, we would find that Y is equal to 60. Last, let's interpret the solution. We got 15 and 60 for X and Y. Looking back at what our variables mean, X was our loaves of bread, so 15 loaves of bread, and 60, which is Y meant bags of popcorn. So there were 15 loaves of bread, 60 bags of popcorn. And we can quick double check that this makes sense. Together, are there 75 items? Yes. Is there 4 times as much popcorn as bread? Yes. So it fits both of the information pieces that we were given to begin with. Check your understanding. Read through the situation and answer all 3 parts. Pause the video now and complete this check. Check your answer. First, the 2 equations for hamburgers and hot dogs. You should have picked B and E. So first, there's a total of 45 hamburgers and hot dogs. So if we combine the 2 together, there are 45 items. That's what it's saying down here in E. Hamburgers plus hot dogs is 45. Then, he cooked twice as many hot dogs as hamburgers. To do that, we find one of them is twice as much as the other, which both of these are written similarly, so we have to check what each variable means. X is representing the number of hamburgers, Y represents hot dogs. So to get hot dogs, there's twice as many hot dogs. So I would take my hamburgers, which is X, and multiply that by 2 to get my hot dogs. So if you picked A, you just had your variables switched. What is the solution? You should have found 15 and 30. To get that, let's use substitution. If Y equals 2X, I'm going to plug in that for Y. So I have X plus 2X down here. I plugged it in, equals 45. X plus 2X is 3X. Remember, there's a hidden 1 here. 3 times something is 45, so X must be equal to 15. If X is 15, multiply that by 2 to get Y, so Y must be twice as much, which is 30. What does this mean in the context? He cooked 15 hamburgers and 30 hot dogs. Going back real quick to this equation here for A, if you had picked A for your equation and used X equals to Y, when you solve it, you would go in and you would actually get the same values. However, your coordinate would be backwards. You would say 30 was X and 15 was Y. If you check to make sure that it makes sense in the context, adding them together, there is 30 and 15, so there still would be 45 items. So that part would be fine. But saying X is hamburgers, this is saying 30 hamburgers, 15 hot dogs. But hot dogs should be twice as many. Here it's saying hamburgers is twice as many. So you could get to the end and realize that you had your variables backwards. It happens. Please double check that what you get as your answer makes sense in the context and the information that you're given. Example 4. Write and solve systems of equations. Gregory's Motorsports has motorcycles, which have 2 wheels, and ATVs, which have 4 wheels. that are in stock. The store has a total of 45 vehicles that together have 130 wheels. Write and solve a system to determine how many of each vehicle the store has in stock. So we want to know how many vehicles, so how many motorcycles and how many ATVs. Let's look at the clues that they gave us. First, the store has a total of 45. So if we add all the motorcycles and all the ATVs, we get 45. It also tells us there's a total of 130 wheels, and that motorcycles have 2 wheels and ATVs have 4 wheels. So the total of all the wheels is 130. If we let X be the motorcycles and Y be the ATVs, our two equations then would be X plus Y is 45. So we add the items together. And then down here, we are saying how many wheels each has to get our total number of wheels. If you're not sure what things to put together, think about it this way. Items plus items equals items. Down here, I have a total of wheels. So I need to know wheels plus wheels to get to wheels. That way I put the correct values together. Motorcycles was X, it had 2 wheels. ATVs was Y, it had 4 wheels. Now that we have our equations, let's decide which method to use. They're both set up. Something X plus something Y equals a total. So let's use elimination. It wasn't perfectly set up to use elimination. So if we multiply the top equation by -2, we can get opposite coefficients. So the bottom one just stayed the same. Multiplying by -2, I get -2x minus 2y equals -90. With opposite coefficients, I can add the two together. This would eliminate x. -2 plus 2 is 0. -2 plus 4 is 2 for my y's. -90 plus 130 is 40. Now I can solve for y. 2 times y is 40, so y must be 20. Now to figure out x, I'm going to take my 20 and plug it back in. So 2 times whatever x is, plus 4 times, now I know y is 20, equals 130. So I'm using the equation for the wheels. This is 80. So 2 times something plus 80 more wheels is equal to 130. Subtract 80, I get 50. So 2 times something is 50, so x must be equal to 25, which is what we got. We also could have just used our original equation here. X plus y is 45, but now I can use that to check. Are my two values added together equal to 45? Yes. 20 plus 25 is 45, and that's how many vehicles there were in total. Last, let's interpret our solution. So we got 25 for X, 20 for Y. X was motorcycles, so the store had 25 motorcycles. Y was ATVs, so the store had 20 ATVs. Check your understanding, read through the situation, and answer all 3 parts. Pause the video now and complete the check. Check your answer. Your two equations were A and D. There's 2 bagels, 1 can of orange juice equals $8. There's that. 3 bagels and 2 cans is 13. So 3 and 2 is 13. There's that one. What's the solution? You should have got 3 and 2. And what does that mean in this context? Bagels were $3 each and orange juice was $2 per can. For these two to set them up, we have 2x plus y equals 8, 3x plus 2y equals 13. I would just multiply this top one. Here's a 1. So I would multiply this by 2. Then I can get 4x plus 2y is 16. Then with this bottom one, 3x plus 2y equals 13. Now that I have my y's as the same coefficient, I can just subtract. So 1 more x, 4 minus 3 is 1. So 1x, that subtracted is 0. 60 minus 13 is 3. So subtracting would tell me right away x is 3. If x is 3, 2 times 3 is 6, plus something is 8. So y must be equal to 2. So that one was pretty quick to solve with elimination if you just multiply the equation by 2. You also could have multiplied the top one by 3. and the bottom one by 2, and both of them could have had a coefficient of x as 6. Either way, whatever you're doing, if you can use elimination and you set it up correctly, you should find that bagels were $3 and orange juice was $2.